Hey guys, so this video is about Lab4 Capacitor. So in this lab, students are going to explore the characteristics of capacitor using a simulation and video. Since students don't have a kit for this lab, so they would be using simulation and video. This part here, introduction, it gives nice theoretical background here, because some of the students may not be in the lecture, they may not have covered about capacitor in their lecture yet. So this is nice, background for them. So useful equation here is this, equation of determining capacitor of parallel plate capacitor when you have a dielectric uh, dielectric material, and then this equation here is a capacitance of a capacitor for parallel plate capacitor when there is when air is a dielectric here, basically, right? So that's kappa equal to 1 here. And then Q equal to CV, just the equation for capacitance of capacitor, and then how the voltage, electric field, and then the separation of plates are related to the voltage between the capacitor. So here, this is a pre-lab, we will skip this part here. So let's look at what's there. Part 1, capacitor characteristics. So students are going to use the fit simulation here. Make sure students check all of these boxes here. Okay, so they should be checking in all of these boxes here so they can see what is displayed here, and they should also check all of these boxes here. And then so what they are gonna do here is, so if you look at setup here, we have a battery here, we have a plates here, right? And then the separation of the plate is given, plate area is given, plate separation is also given. So students are going to determine, see what happens to the capacitance, basically, if they change this separation here, change the area of the plate, or change the separation between these plates, or if they increase or decrease the amount of battery, or voltage, basically. Okay, and then just record that right here. So what happens to the quantity or capacitance of a capacitor, charge, so the things they are going to be looking at, right? So, and then what they are going to do for this capacitance of capacitor is, change the value of D, and then see what happens, change the value of A, area A, and what happens, change the value of battery, right? Potential, electric potential of a battery here, and then see what happens to value of C. Do the same thing here for the charge, again, on each plate, right? Whether the charge changes, what happens to when the separation between the plates changes, when the area of the plates changes, and when the voltage of the batteries increase. And then they do the same thing here for voltage across the capacitor, and then electric field between the plates, and stored energy of a capacitor. So all of these should be, students should be able to do it, like, since they have all of these here, right, displayed here. So that should be pretty straightforward. So this is where they are going to connect the battery and see this. This part they will repeat the same thing above, but they will disconnect the battery and see what happens here. Okay, so that's the difference between those two. So part 2 is about calculating the permittivity constant here. So again, permittivity, they are going to be calculating the permittivity constant of air, right? If you remember the equation, C equal to epsilon naught A by D, so that's what they should just do that. So here, for this part, so look at this. You will make a graph. So the student will be using a graph of capacitance versus area, and then this, they will just look at the value of a permittivity constant. So here students may need help here, because some of them may have forgotten, or some of them may need help with how to relate the slope of the graph with the permittivity constant they are looking for. Okay, so please look at that, or just make sure you could help out a student with that here. And once they have that value, they can compare their value with this permittivity of vacuum here, 8.85 into 10 to the minus 12 farad per meter. Okay, so that's the value. Okay, so now here that is for permittivity of air. Here students, in the next part here, students are going to actually use the dielectric. Okay, so in this simulation they would be using a dielectric material, and then repeat really the process whatever they did before, and then answer these questions based on their data. So as we insert the dielectric, right, electric field should increase, the capacitance of a capacitor should increase, right? So and then they will just write down all the value here from the simulation, and then finally just explain what happened if what happens when the capacitance, what happens to the capacitance in presence of dielectric and in absence of dielectric, right? So that's the question to answer. Part 3 is energy stored in a capacitor. Here students are going to use the pivot interactive, and then what they are going to do is they are going to, so here they are going to, let's see, collect the data. So let me read through here. So here, if you go here, power, so a power supply charges a capacitor to some voltage. The capacitor is then disconnected from the supply and connected to a motor. As the capacitor discharges and transfers its stored energy to a motor, the motor rotates. The number, this part is the important part. For the number of revolution of the motor is proportional to the amount of energy transferred. But this is the whole key point for this part. So basically students are going to look at the voltage, note down the voltage, and then look at the number of revolution of the motor. So really like frequency, right? So and then they are going to plot a graph so that they can relate capacitance of a capacitor so that they can relate the number of revolution with the energy and the capacitance of a capacitor. Okay, so since this number of revolution of a motor is proportional to the amount of energy transfer, like if we go back to the equation for energy stored in a capacitor, we can kind of replace in place of u, assume in place of u, we can say number of revolution, let's say f, right, like frequency f, and then just make a graph, right? So so here is what so students need to linearize their data, and then from that data their data should so here collect that, this part is collect the data, voltage and number of revolution for each video in the first part of the activity, and then they can either copy the data or they can just look at the video and make their own table. And then once they have a graph, so here this asks student to, this part asks student to figure out on their own how to how do they they should write their, put their data, right, for to get the how do they need to linearize their function basically. Okay, and then use your graph to write a best fit equation that relates the voltage applied to the capacitor and number of rotation. Then use this equation to predict how many rotations that motor will make if 20 volt is applied to the capacitor. Do not include the video of the 20 volt experiment in the data you use to make the prediction. So here basically they will have a graph, right, their graph for up to some voltage, and then using their best fit equation, right, they can just insert this value of 20 volt and predict what predict the number of rotation, right, for 20 volt. Okay, so that's about it here. So that's about it here. So students need to linearize their data, and then from that data so here collect the data, voltage and number of revolution for each video in the first part of the activity, and then just same these questions are just based on here. So this part is for a student. What questions do you have? Yep. What questions do you have about capacitor that you can explore? Okay, that I'll leave this for a student. I'm not going to talk about this one here. So that's about it. So this lab is kind of pretty straightforward. If you have a question, let me know. I think that's about it. Okay. All right, I'm going to stop recording this.